So we're finishing up on applications of Extrema, finding where we have a maximum value or minimum value. And we're looking at applications, like I just said, and the problem in front of us says a local club is arranging a charter flight to Hawaii. Nice. The cost of the trip is $1,600 each for 90 passengers with a refund of $10 per passenger for each passenger in excess of 90. So we want to find the number of passengers that will maximize the revenue received from the flight, and we want to find that maximum revenue. Okay, so our fundamental function is maximizing revenue. So the revenue, this is going to equal the cost, right, of the flight. And it's going to be times the number of passengers. Yeah, when that happens. Passengers. Okay, so we need to write this out and pick out stuff that we know. So the trip is going to cost us $1,600 for each 90 passengers. So maybe we can let C equal the cost. And let's assume that C, let's see, okay. And let, I don't know, P equal number of passengers. If we let, how about we let X, because we got to kind of figure out what we're going to do. Let X be the number of passengers that exceed 90. So the number of passengers that we're going to have, this is going to equal 90 plus X. Let's just stop for a second. Okay, I wasn't sure if I was recording first. And anyway, so we have X equals the number of passengers that exceed 90. The cost of the trip is $1,600, and we're going to give a refund. So if we do it this way, the cost is $1,600. And then it's going to be minus $10 for every person that exceeds the 90, so times X. And so here we know revenue. We have the 1,600, the cost minus 10X, all times the number of passengers, which is 90 plus X. And we're trying to maximize this. Well, I don't want to use the product rule, but I know I could also distribute, and we can bypass the product rule when we take the derivative. So I have 1,600 times 90. That gives me 144,000 plus 1,600X minus 10X times 90X is 900X. And then I have a negative 10x times an x gives me a minus 10x squared. So I get my revenue function, rewriting in descending order powers is negative 10x squared. 1600x minus 900x, that's going to give me plus 700x plus 144,000. So we're trying to maximize this, and we can find where maximum value occurs by taking the derivative and finding our critical numbers. And we're finding our critical numbers by setting the derivative equal to 0. So let's take the derivative of this. And so taking the derivative of negative 10x squared, we get negative 20x plus the derivative of 700x gives us 700. We're looking at when this is equal to 0. So I have negative 20x equals negative 700. So divide both sides by negative 20. So 700 divided by 20 gives us 35. So I'm thinking that 35 is my number. And let's look at making sure that this is a max. So there's a couple ways that we can see that this is a max. We can, if we want, let's use our second derivative test. So if we use our second derivative test, so taking the second derivative of negative 20x is equal to negative 20. Derivative of a constant is 0. So if we plug in our critical number, 35, wherever we see an x in our second derivative, which there is none, we get negative 20. This is less than 0. And we remember that told us it was concave down. And that tells me that that is a max at 35. We don't want to minimize the revenue. We want to maximize it. So we just wanted to make sure that that was a max. This is not, though, the number of passengers, right? They wanted to find the number of passengers. This was, we let it be the number of passengers that exceeded 90. So the number of passengers that will maximize revenue is actually that 90 plus 35. Which is 125 passengers. So that was part A. Part B wants us to find the maximum revenue. Okay, well, we found our revenue function. We can use this one if we want. We can use the one that we expanded if we want, but we need to go in there. And this, we're plugging in though 35 because X was the number that exceeded. So we're going to look at R of 35. And so that would equal 1600 minus 10 times 35. And then that quantity is times the quantity 90 plus 35. Order of operations, let's simplify inside the parentheses and then we can multiply. And so we have 1600 minus 10 times 35, so 350. And then we have 90 plus 35, which is 125. So the cost is 1,600 minus 350, which gives us 1,250. for the cost of the flight times the 125 passengers. And so this is equal to $156,250. $250.